Okay, so the truss in the rod AB in the pin jointed truss ABCD is. So you can see, if I see if this is the truss, so obviously all the joints are pin joint, all the members are jointed with pin. So if I talk about joint D, so here we have, if I draw its free body diagram, then here we have these two forces. This is FDA and this is FDC. So can you tell me, is there any force which is acting along this which balances this force? And is there any force along this which balance this force? Obviously these two forces are not available here. So simply can I say this is 0 and this is 0. So summation of net horizontal force equal to 0. If you write, then you will get FDA is equal to 0. And similarly, when you write summation of vertical force is equal to 0, then you will get FDC is equal to 0. So no meaning of this section. Is it clear? So now if I again apply method of joint for joint C, so at a joint C you will get like this. This is P and this is TAC and this is TBC. Yes or no? And in between here we have angle theta. Let's say this angle is theta. So can I say TAC? Obviously TAC has two components, one is vertical and another one is horizontal component. So simply if I write summation of vertical force is equal to 0, so simply here we can get TAC, this is sine theta is equal to P. So from this we can say TAC is equal to P over sine theta. And similarly, if you apply summation of horizontal force equal to 0, so what about this? TBC is nothing but this is minus TAC cos theta, or simply you can say this is minus P by cos theta into sin theta. Yes or no? Here we have sin theta into cos theta. So this is TBC. Is it clear? Okay, so now if you see for this, so in both the cases, can I say here we have horizontal reaction, that is RHB, and here we have vertical reaction RBB. Yes or no? So, and similarly for this, if I say this, there is no force, here we have one force. Yes or no? Which is acting, which is tension. Yes or no? And tension is always represented by towards the joint. Yes or no? Correct. So if this force is acting like this, so it's obviously its component is acting downward, so the reaction must be acting in the upward direction. Yes or no? Can I say like this? Yes or no? Correct. Or any direction you will consider, no need to worry about this. Suppose if you consider this is vertical direction, then it will be definitely acting in the downward direction. Yes or no? And obviously I already told you, here we have tension like this in this string, which is P sin theta. Yes or no? And this is positive value, it means here we have tension. So it's a horizontal component. So this is vertical reaction, that is RVA. Yes or no? So we need to find out how much actual net force acting on the member AB. So net force acting on the member AB is nothing but, can I say this is RVB minus RVA? Yes or no? And similarly, if you apply summation of vertical forces equal to 0, so can I say this is RVB minus RVA is equal to P? So let's say this is equation 1 and this is equation 2. So from this, can I say net force acting on the member AB is nothing but this is P? Yes or no? This is P. Yes or no? Instead of RBA minus RBB, you just put this P value. So what about stress? So stress acting on the AB member is nothing but this is force upon area. And what about area? This is pi by 4 d square. So simply can I say FAB is nothing but this is 4p over pi d square. 4p over pi d square. So the correct option is option B. So no need to write this solution. Only these two steps are enough to solve this question. Otherwise, if you want to write tension on the string AB and AC and BC, then by using this method you can solve it. Yes or no? Okay, so let's see another problem again from trusses. This is very simple question. Simply you just write, you just apply method of join, and obviously here you will get a tension, that is T yx, and here you will get T yz, and both are making same angle. So can I say this is 120, this is 120, and this is 120? The whole system is symmetric. Yes or no? So Tyx over sine 120 is equal to Tyz over sine 120, and this is equal to 200 over sine 120. Yes or no? So simply here you get Tyx is equal to Tyz is equal to 200 Newton. Is it clear? This is very simple question. So option B is the right option. Okay, so again you see this is a very last truss. The force is member BC of steel truss structure as shown in figure. The cross section of each member is A, length of the member is L. So you need to find out force acting on the BC section. So here we have BC section. So if you apply method of joint, then you need to solve first this joint, then this joint, then you move this. So this is lengthy process. To avoid this, we just use method of section. Yes or no? So you just cut a section from here. So after cutting this, you will get this result. Is it clear? It is looking like this. This is our right portion of the truss. This is P2 and this is 2P1. Correct? And this is joint D, this is joint C, this is G, this is H, this is J, and length of each member is L. So this is L, this is L, this is L. Yes or no? In this we have F CB, and in this we have FGB. Correct? And in this we have FGF. Is it clear? So let us take summation of moment about G is equal to 0. So can I say P2 into 2 times of L, this is acting in clockwise, plus 2 times of P1 into L, this is also acting clockwise, minus FCB into L, this is anti-clockwise, that's why it will be taken as negative. So from this simply you get FCB is equal to 2 times L P1 plus P2 over L. So L is cancelled out with this. So simply here we can get FCB is equal to 2 times of P1 plus P2. Yes or no? So this is final solution. Okay. Okay, let's see another truss we have. So let's see how to solve this problem. So this is little lengthy question, correct? This is little lengthy question. So you can see, if I assume this truss member can extend up to this symmetrically. Yes or no? Correct? And if you extend this like this due to this load P, correct? So this length is L1, this length is also L2, sorry, this length is L1, and this length is L3, and this length is L2. And can I say L1 is equal to L3? Yes or no? But not equal to L2? Yes or no? So now you can see this vertical length L2 is given here, that is 1.6 meters. So what about L1 or L3? So simply if I join, then here we can get a triangle like this. this length is L and this is 1.2 and this is equal to 1.6. So can I write this is square root of 1.2 square plus 1.6 square, and after this you will get L1 is equal to L3, this is equal to 2 meter. Is it clear? So now if we can apply a free body diagram for this point, so can I get this result? This is P3 and this is P1 and this is P2, and obviously P1 is equal to P3, and if you resolve these two forces and let's say this angle is theta and this is also theta, so simply can I say 2 times of P1 cos theta plus P2, and obviously here we have a downward direction P2 is equal to P. Can I write this? Because the component of P1, its vertical component of P1 is nothing but this is P1 cos theta, and similarly the vertical component of P3 is P3 cos theta, and since P1 and P3 is equal, so simply we can write 2 P1 cos theta plus P2 is equal to P. Yes or no? And let's say this is equation 1. Is it clear? And what about theta? If you write this is theta, so can I say parallelly here I am writing cos theta is equal to base, that is 1.6 over perpendicular hypotenuse. So from this here we can get 36.88 degree. Yes or no? Now if you see this triangle, this is smaller triangle, correct? And in this if I apply compatibility conditions, so can I say this is delta L2 and this length is delta L1? Yes or no? And this angle is theta. So simply can I say delta L1 is equal to delta L2 cos theta? And what about delta L1? Instead of delta L1, can I write this is P1 L1 over A1 E1 is equal to P2 L2 over A2 E2 cos theta? And cos theta we already know. So from this relation, can I simplify? Can simplify me? P1 by P2 is nothing but this is L2 by L1 cos theta. Yes or no? And once you get this result, so simply here we can get P1 by P2 is nothing but if we put L2 by L1 value here and cos theta value, so simply here we can get this is equal to, I'm directly putting cos theta is equal to, you just put 36.88 and L2 by L1 is given already. So after putting these values, simply here we can get 0.64, and let's say this is equation 2. So can I say from equation 1 and 2, because we have two equations for P1 and P2. So when you put this P1 value on the equation 1, then you will get P1 is equal to 31.62 kilonewton, and similarly if I talk about P2, then here we can get 49.4 kilonewton. Yes or no? So obviously from this we can get P1 and P2, and once you get P1 and P2, so can I say now the sigma A, let's say sigma A is allowable stress? Yes or no? And which is equal to 40 over 2, because for factor of safety is 2 is given here. So simply we can say this is 200, this is sigma permissible. Let's say this is sigma permissible, or you can say sigma A, which is allowable stress. Is it clear? So now you can see the stress induced in the string 1 should be less than equal to permissible. Yes or no? And what about sigma 1? Can I say this is P1 upon A1 less than equal to sigma A? Yes or no? And you need to calculate A1. So can I say A1 is greater than equal to P1 over sigma A? Sorry, this is, yes. And what about P1? P1 is nothing but this is 31.62 into 10 power 3 over, what about sigma? This is 200 megapascal. So when you simplify this, then you will get A1 is greater than equal to 158.1 millimeter square. Yes or no? Correct? 158.1 mm square. This is total area. Is it clear? And once you get this area, then if you simplify this, then option C will satisfy the same result. Because when you see the ratio 25 by 13, then you will get same result. And this is obviously which I have calculated here. This is in millimeter square, and this ratio is given in centimeter square. So simply if you divide 25 with 13 and multiply with 100, then you will get 100, same result. Yes or no? So 15 by 13 centimeter square, option C is the right option. Correct? So this is the procedure to solve this question. So this is little lengthy question. Okay, so what about this? A perfect frame is that which satisfies the equation. Assume n is equal to number of joint. This is very simple question. Number of joint is n is the number of member and j is the number of joint. So obviously we know that this relation n is equal to 2j minus 3. This is condition for perfect truss. This is condition for perfect truss. Yes or no? And if n is greater than 2j minus 3, then this is redundant truss. Yes or no? Imperfect and redundant. This is redundant truss. Yes or no? And similarly, if n is less than 2j minus 3, then this is deficient truss. Deficient truss. Yes or no? So this is the condition. So n is equal to 2j minus 3. Option D is the right option. Okay. So what about this? Another question we have. Again from truss. Is it clear? So let's see. A simple structure ABCD is supported on a hinge at A, and you can say this is a hinge. On B we have roller support. So simply can I say here we have vertical reaction, that is RVA, and here we have horizontal reaction, that is RHA, and here we have only one vertical reaction, that is RVB. Yes or no? And horizontal force 10,000 kilonewton is acting here. Yes or no? Determine the forces in the member AC. We need to find out force in AC member, this member. Is that clear? Correct? So let's see how to solve. So first you need to write determine reaction. So simply can I say summation of horizontal reaction is equal to 0. So RHA is equal to 1000 kilonewton. Is that clear? RHA is equal to 1000 kilonewton. What about summation of vertical reaction? This is RVA plus RVB. This is equal to 0. Let's say this is equation 1. Next, summation of moment, if I take about A is equal to 0. So simply can I say this is RVB into 1 meter minus 1000 into this perpendicular distance. So first you need to find this distance. And if I say this is symmetrical triangle, so can I say this is 1 by 2? And what about this? So simply can I say this is 1 square minus 1 by 2 whole square? Yes or no? And this is nothing but this is 1 minus 1 by 4. So this is root 3 by 4, or simply you can say root 3 by 2. This distance is root 3 by 2. Yes or no? So simply you multiply with root 3 by 2 plus 1. Yes or no? And this is equal to 0. So after simplifying this, here we can get RBB is equal to 1870 kilonewton. 1870 kilonewton. And once you get RVB, so can I say RVA is nothing but this is minus of 1870 kilonewton. And this minus sign indicates the assumed direction of RVB is wrong. It will be acting in the downward direction. Yes or no? Yes or no? This reaction is acting. Actually, this reaction acting in downward direction. Correct? Now we need to calculate force acting on the AC member. So in this we have you can see if I apply this method of joint here, or can I directly apply for method of joint for A? for joint A. So simply you get, here you have RHA, here you have RVA, this is inclined, and this is FAD, this is FAC, and similarly here we have FAB. So first you need to find out FAB, because we have three unknowns, so we cannot solve. So let's say if we apply method of joint for B, this, let's say this is B. So here we have RVB, yes or no, and here we have FAB, and here we have FBC, and there is no force, yes or no. So obviously RFB, RFBB is balanced by FBC, yes or no. But FAB, there is no balancing force, so this will be 0. So FAB will be taken as 0. Is it clear? So there is no force which balance this FAB force. So in this there is no reaction. So simply we can say FAB is equal to 0. So now it is very simple. You just you know this is horizontal reaction. So you just simply, if this angle is theta, and obviously this is 1, this is 1, so this will be 45 degree. So simply can I say RHA is equal to FAC cos 45. So from this, FAC is nothing but simply RHA, which is 1870, sorry, 1000, not 1870, this is 1000 kilonewton, 1000 kilonewton over cos 45. And if you simplify this, then you will get 1414. This is cos 45 means 1 by root 2. So 1000 into 1 root 2, 1000 into root 2. This is 141 kilonewton. Is that clear? So this is the correct answer. So option D is the right option. So first you need to determine reaction, then you apply method of joint for joint B, then you apply method of joint for joint A, then you will get the answer, yes or no. So this is all about this question. A question from Trusses and simple load system of forces.